for me, positive pressure ventilation systems are kind of sold one way and actually in reality, I think work another way. So they're kind of sold on this positive pressurization thing, but the problem with that is, well, there's several problems with it. One is that if you're pushing out the moisture-laden air, you're also pushing out the heat-laden air, if indeed there is warm air in your house. So that's a bit of a problem to me. It doesn't sort of make sense. So they're sold on air change rates and positive pressurization. I suspect how they really work is air movement. So if we can keep the air moving, there's less likelihood of condensation forming. And, well, I'm kind of getting right into it now. The reality is these systems operate night and day. We're told by the kind of manufacturer, or it's implied that they will only operate when the ceiling temperature is higher than inside the house. But I know that to be not the case in most operating systems. They might flow on a reduced rate, but most of those systems actually will blow into the house at night. And the roof space air at night, there's no way it's warm. It's absolutely cold air that you're blowing into the house. So part of the suspicion is that how these things actually work to reduce the formation of condensation, and I'm going to come back to that point in a second, is partly what they're doing is dropping the inside temperature inside the house. So the dew point is formed by a combination of the inside temperature, the inside relative humidity, and the outside temperature. So the dew point is where condensation will form when all the characteristics inside the home environment are just right for that condensation to form. So, for example, we can look at if we had an indoor temperature of 20 degrees and indoor relative humidity of, say, 70%, and an outdoor temperature of, well, let's say 5 degrees, our dew point, which we can calculate off charts, so I'm just going to make one up, but our dew point that we can calculate off charts might be 13.9 degrees under those sort of circumstances, something roughly like that. So what that means is when that surface, whatever that surface is, and it's most likely to be a window because they transfer heat very well, so they get very cold. When that surface gets down to that 13.9 degrees or whatever it is off the charts, we can go, oh, well, that's when, with this much moisture in the air and these temperatures, that's when condensation will form. It's easy to have quite a high dew point in that your surfaces don't have to get that cold when it's really freezing outside. And the more moisture you have in the house, again, the higher that dew point's going to be. So when we've got a house that's really wet inside and it's a cold winter's night, there's condensation on the walls as well as the windows. And that's what, and in really, really bad houses, you wake up and the bed covering's damp because it's, that's become the dew point and the carpet's damp and the walls and everything's damp. And in the bathroom, we can get it on a reasonably warm day because we just massively saturate the air. We're at 98% relative humidity. So even when the wall surface is 20 degrees, you can still get condensation. That's the dew point. The dew point is a phenomenon of having a difference between an inside temperature and an outside temperature. So the less that difference is, the more flexibility we have with the dew point, I guess, is the truth of it. But we want to live in houses where it's really warm inside, even when it's cold outside. So we need to deal with and this is where the good building science comes in, we need to deal with the amount of moisture in the air. And these systems, positive pressure ventilation systems, there seems to be no proof that they change the moisture levels in the house at all. In fact, the evidence is, and Beacon did a study on this themselves, the evidence is that during the day, the roof space air is most likely more damp, i.e. it has higher relative humidity than the air inside the house. It'll be warmer than the air inside the house. So in the daytime, you're pumping in warm air, but it's wetter air. So warm, good, wetter, bad. At nighttime, you're pumping in cold air, so bad. It's arguably drier air because it's colder, so that's good. but the overall effect is questionable to me anyway, in that what these systems do really is they reduce the formation of condensation. Now, condensation is a symptom of a poorly performing house. It's a house that's getting too cold, it's poorly insulated, and has high moisture load in it. That's why we get condensation. So if we can look at the cause of the problem and fix that, rather than trying to kind of deal with a symptom of the problems, that to me makes a lot more sense. And really, they're not even dealing with the symptom, they're kind of masking the symptom, if you like. Because if the reality is that the way they're getting less condensation to form in houses that are running these systems is by lowering the internal temperature, that makes no sense to me. We know that cold houses in New Zealand are already an issue. We know that cold houses in New Zealand are killing people. So we certainly don't want to be adding to that in any way, shape or form. And that is my experience out in the field, is that people report, oh yes, we got rid of all the condensation. They're not monitoring their homes with hygrometers. So if they can't see condensation, they make the assumption that the house is drier. And arguably in some cases it will be drier, because in some houses there wasn't enough ventilation initially. But I would argue in most houses with positive pressure, you're now massively over-ventilating the house to no good gain. So people report, oh, my condensation's gone, the house must be drier. And then you question them about the temperature and they go, well, it's quite cold. Yes, we do have to run the heat pump all the time, or the wood burner or whatever it is. So, but they're quite happy that they've got less condensation forming. But is the house drier? Often not. Is the house warmer? Often definitely not. It's definitely colder in the house. But because they can't see that end result of all these other problems, they're going, oh, great, mate, great. The analogy I give to my clients is I say, well, if you came to me for a bad back and I gave you an aspirin, have I fixed your back? No. The pain of your back's gone away, but I haven't fixed your back at all. It's going to be back tomorrow. So to me, selling a system that floods a house with air, I'm back to positive pressure now, that floods a house with air at high rates, sometimes damp air, sometimes cold air, seems to have, in most cases, the effect of lowering the temperature in the house, seems to have no effect on changing the relative humidity levels in the house overall. In fact, pushes them up in the day. But it's making people think that their house is performing better because they can't see the condensation. And that's actually my big issue with this, with positive pressure, is it's not, I don't care that some company's getting rich for selling something that doesn't really deal with the problem. That's not my business. My business is that there's an awful lot of people out there who think their home is performing better, therefore it's healthier, when in fact it's not, because of the temperature part of it. And is it any drier? No, not necessarily. So it's not that this is a benign thing. It's actually doing harm because you're taking people's focus away from what the real problems are, which is cold, damp housing. And that's fixed by ventilation, heating, controlling moisture, and good ventilation practices, not necessarily by positive pressure ventilation. And look, there's no question that condensation is a huge problem in New Zealand homes. There's no question of that. That's absolutely right. We need to address moisture levels in our homes. But I don't think this is the first port of call to do that at all. I think it would be the very last port of call to do that. There is no situation where I would recommend that you take your ceiling space air and pump it into your house at really high rates. No, I can't think of the situation where that is the solution. I really can't. I can think of situations where you'd want to insulate the property, heat the property, ventilate the property, control the moisture in the property, but I can't think of a situation where I think it's a great idea to pump tons of ceiling air into the house. No, can't think of where that would be.